Welcome back to the Intelligent Founder AI podcast. This episode is for the moment when your infra spreadsheet suddenly says something uncomfortable. Buying your own GPS might actually be cheaper than renting them. This episode is for founders who are either approaching the scale where on-premises hardware starts to look compelling, or who are operating in a sector where control over their infrastructure is not optional but mandatory. Both groups are larger than you might think, and both groups often wait too long to have this conversation. Let me state the conclusion first because the evidence is clear and I want you to hear it before the caveats. For sustained, predictable, high-volume inference workloads, on-premises infrastructure is the mathematically superior choice once GPU utilization consistently exceeds 60%. Below that threshold, the flexibility of cloud rental justifies the premium you pay. Above it, the savings compound every single month for the full lifetime of the hardware. We are talking about a decision that can save hundreds of thousands of pounds over a 3-year period on a single server node. Factory app. Let me walk through the maths in concrete terms. An 8-GPU H100 server costs roughly $250,000 to $400,000 to purchase, depending on configuration, vendor, and timing. Operating costs, co-location space, power, cooling, hardware maintenance, and networking add somewhere between $3,000 and $5,000 per month. If you take $250,000 as the acquisition cost, add $4,000 per month in operating cost, and amortize over 3 years, the monthly effective cost is approximately $11,000. Now compare that to the equivalent 8 GPU capacity on AWS or Google Cloud on Demand, which runs between $14,000 and $20,000 per month, depending on instance type and region. At sustained 70% utilization, you are saving between $3,000 and $9,000 per month. Over 3 years on a single node, that is between $100,000 and $300,000 in savings. Lenovo Press.Lenovo plus 1. Lenovo's total cost of ownership analysis published in early 2026 quantified this at the token level across different deployment configurations. Self-hosting on owned infrastructure offers an 8 times cost advantage per million tokens compared to equivalent cloud IaaS GPU rental, and up to 18 times compared to calling frontier model AP-IS. The 8 times figure is the like-for-like comparison to GPU rental. The 18 times number assumes you have also moved off premium-hosted AP-IS and are running open-weight models on your own hardware. Both are achievable. Both require operational investment to realize. Lenovo Press.Lenovo. The critical variable, the one that everything else depends on, is utilization. This cannot be overstated. At 10% GPU utilization, on-premises hardware is actually more expensive per effective GPU hour than most on-demand cloud rates. You are paying for 90% of a very expensive asset that is sitting idle. At 70% utilization, the effective cost per GPU hour falls well below typical reserved cloud pricing. And the decision is clear. The break-even utilization threshold, the precise rate above which on-premises becomes cheaper on a 3-year total cost of ownership basis, falls between 55 and 75% depending on your electricity costs, your co-location rate, your hardware amortization schedule, and which cloud pricing tier you are comparing against. Use your actual data to find your specific threshold. Do not guess hub.stability. Now I want to be very direct about what on-premises hardware actually costs beyond the purchase price, because this is where founder assumptions diverge most sharply from reality. First, power and co-location. Modern H100 servers draw 6 to 10 kilowatts of power per rack unit. Your office cannot handle this. A standard commercial office building has a power density of roughly 1 to 3 kilowatts per rack. GPU servers need 6 to 10 kilowatts. You need a professional data center or co-location facility with high-density power circuits, dedicated cooling infrastructure, and appropriate fire suppression. In the UK, professional co-location costs between £500 and £2,000 per rack per month depending on location, power density, and connectivity level. London and major city locations are at the higher end. Purpose-built AI data center facilities outside major metropolitan areas can be more cost-effective, but add network latency for inference workloads, stability. Second, people. This is the cost that destroys the on-premises economics for small teams, and it is the one that is most often left out of cost comparisons. Running GPU infrastructure at production quality, meaning high availability, low latency, proper monitoring, fast incident response, requires at least one, and ideally two, engineers who deeply understand GPU drivers, CUDA, containerization platforms like Kubernetes, model serving frameworks, storage systems, and reliability engineering. Finding people with this combination of skills in the UK is not easy. At current UK market rates, a senior ML infrastructure engineer commands between £80,000 and £140,000 per year in base salary plus benefits. If on-premises infrastructure requires one dedicated engineer, that salary cost alone can exceed the hardware savings for teams at modest scale. This calculation needs to be explicit in your decision.scopx. Third, redundancy and resilience. A single GPU server failure in production means downtime. Downtime means unhappy users, broken SLAs, and potentially worse outcomes in safety-critical applications. Proper high availability architecture requires at minimum a hot spare for your most critical workloads, or a clearly defined and tested fallback path to cloud infrastructure. Either option adds cost and complexity, neither is free. Fourth, hardware depreciation risk. GPU technology is moving fast. An H100 purchased today represents the state-of-the-art as of roughly 18 months ago. Blackwell B200G. B200 hardware is already showing significantly better inference efficiency per dollar for many workload types. When you own hardware, you are locked into its performance ceiling for the duration of your amortization period. If a new architecture emerges that is dramatically more efficient for your specific workload, you cannot simply switch to it without writing off your existing investment. Cloud and rental infrastructure gives you the ability to adopt new hardware generations as they become available without capital write-downs. Markets. Financial content. Having said all of that, the hybrid architecture is often the right answer and sidesteps many of these constraints. The practical approach for most teams that have validated their production workloads is to route the predictable high-volume baseline of their inference traffic to amortized owned hardware, and keep a cloud or rental capacity allocation for the burst tail of the distribution. The traffic that exceeds your baseline by more than your on-premises capacity can handle. This hybrid model has been shown to reduce blended AI infrastructure cost by 40 to 60% compared to pure cloud. It requires operational maturity to implement well, but it is the architecture that most mature AI product companies converge on, and it is worth planning toward from early in your infrastructure journey. Factory app. For regulated verticals, aerospace, transport, healthcare, financial services, there is an additional dimension to the on-premises calculation that we will cover in full in Episode 7. The short version is that the UK AI Safety Institute now requires that AI systems used in critical infrastructure be capable of operating for 72 hours without internet connectivity. That requirement alone makes pure cloud architecture non-compliant for a significant range of enterprise use cases, regardless of the economics. If you are building for regulated verticals, your on-premises evaluation is not a cost optimization exercise. It is a compliance prerequisite. ViewSense. The decision to buy hardware is ultimately an operational maturity decision more than a financial one. The economics work at scale, but the economics only work if your team can operate the infrastructure reliably, if your workloads are stable enough to justify committing capital, and if you have the organizational capacity to manage the additional complexity. Get the operational readiness right, and the economics will follow. This was the Intelligent Founder AI podcast. If today's conversation nudged you from never to maybe on owning hardware, sit with the numbers and send this episode to the one person on your team who loves racks and power budgets. Subscribe to Intelligent Founder AI More Deep Dives. See you next time.